Today we will learn jump statements. Okay, what are the jump statements and how to use it in our program? What are the jump statements? Okay, one is we have a break, then we have a continue, all lowercase. Okay, continue. Then we have a go to, then we have a return. Okay, and then we have next is a exit. So these are jump statements which is going to make the control to jump from one place to another place. Now, when a jump statement, every jump statement can be used in some place, cannot be used in some places. Okay. We studied something called selection statement called if else, then we have studied switch, then we have studied loops. Okay. Now, break cannot be used inside an if. Break can be used in a switch. Break can be used in loops. If you use it, what it will do? What is the result of it? The result. It will take the control outside. It will take the control where? Outside. Continue. Cannot be used in if, cannot be used in switch. It can be used in loops. Loops. What will do? Here we have three loops are there. Okay. One is for. If you put continue in a for, it will take you to updation part. Remember, if you put the continue in a while, it will take you to condition part. If you put in a do while, it will take you to again what in this case it will take you to condition part. In while and do while, you take it to what? Condition, whereas in a for, will take it to what? Updation. Yeah. Go to can be used anywhere. What it will do, it will take the control wherever the label is defined. What's the label? We are going to study. Don't worry about it. Return, you can use anywhere. What it will do, it will take the control outside the function. See, outside of the function. Function. What is a function? We are going to study. Function. Exit, you can use anywhere. What it will do, it will take the control outside of the program. What's the meaning of this? Let us understand. Okay. What's the meaning of this? Let us what? Understand this. Okay. I'm going to put an example there and then how it works. Let us see. Okay. I have written like this. This is my program. Okay. I wrote it right now in this case is print hello. Then I wrote it in this case is for integer I is equal to 1, I is less than or equal to 5, I plus plus, right? Then I wrote it in this case is printf percentage d, here I add a slash in for it, slash in, I added a slash in I, then I wrote it in this case here, I is equal to 3, I put a break, and here I put a printf hi and slash in, and then I wrote here printf outside the by, and then I'm going to say here close the brace, return 0. Yeah, you're a programmer. Sir, you have written you said break cannot be used inside an if, but you have used inside an if. No. I am using the break in the loop, but it will be executed only when the if is satisfied. Therefore, here I have not used inside an if, but I have used inside a loop. But it will take the control outside if the condition is satisfied. Let us see how this works, okay? How it is going to run for me. In this case, I put right now in this place is what? I is what, right? 1. First is hello is printed for me, correct? I is 1. 1 is less than or equal to 5, condition is true, it prints 1. 1 is equal to 3, condition is false, it prints high, then it goes to the next line. Then go for I plus plus, I became 2. 2 is less than or equal to 5, condition is true, it prints 2. 2 is equal to 3, condition is false, it prints what? I became 3. 3 is less than or equal to 5, condition is true, prints 3. 3 is equal to 3. Condition is what? True. Break. Break will take the control where? Outside the loop. This is my loop outside. It prints by. So that means when I is 3, once it broke the loop, it does not execute the remaining statements and will take the control outside. Therefore, what has happened? I did not get high for what? For 3. Got it? So, break will take the control outside in whichever loop it resides. In whichever loop what it resides. Why did I say in whichever loop is in case of nested loop? If you put inside the inner loop, it will take the control outside the inner loop only. It will not take the control where outside the outer loop. Okay. Now, in the place of break, I am going to change it to what? In the place of break, I am going to put continue. What happened? Let us see. Okay. Now, hello is printed for me. Done. I'll change the color for you to understand better. Okay. Hello is printed for me. Done. I is 1. 1 is less than or equal to 5. Condition is true. It prints 1. Correct. 1 is equal to 3. False. It prints I. Correct. I became 2. 2 is less than or equal to 5. Condition is 2. Prints 2. Right. 2 is equal to 3. Condition is what? False. It prints I. I became 3. 3 is less than or equal to 5. Condition is 2. Prints 3. 3 is equal to 3. Condition is what? True. Continue. What the continue will do? It will skip the following statements, take the control to updation. Why updation? Because continue will take the control to what? Updation. Look at now, I became 4. 4 is less than or equal to 5. Condition is true. It prints a 4. 4 is equal to 3. False. It prints what? I became 5. 5 is less than or equal to 5. Condition is true. Prints 5. 5 is equal to 3. False. It prints high. I became 6. 6 is less than or equal to 5. False. It prints what? By. I became 6. 6 is less than or equal to 5. False. It came out and print what? By. Right? Therefore, if you put a continue, the loop will be completed. It will come out, if you use a continue, it will come out only because of this condition only. But when I execute the continue, it will skip the following statement, it will take it to updation. Therefore, after 3, I don't have a high. After 3, I don't have a high. After 3, I did not go to the next line. Why? Because the next line was printed by this. Now let us see here in this case is if I put right now in the place of continue, if I could have put return go to, what will see? Go to, say what will do. I would use go to. Go to can be used anywhere. Okay, inside the brace you can put anywhere. Okay. Go to requires a label where the control has to go. So I am going to put here in this case anything you can write in there I wrote. Where I wrote the there is after printf I wrote there and put a colon. This is called defining the label. If you want to define a label, after defining the label, you have to put a colon. This is called referring the label. With quote, you will refer the label. When you refer the label, you will put a semicolon, remember. So what the control will do, when you execute this statement, it will take the control here. Let us see what is happening. I is 1, first is hello is printed. I is 1, 1 is less than or equal to 5, condition is true, prints 1. 1 is equal to 3, false, it prints a high. I became to 2 is less than or equal to 5, print 2. 2 is equal to 3, condition is false, it prints a high. I became 3. 3 is equal to 3, condition is what? True. Go to there, it comes here and comes out this. Okay, I won't get a by. Why? Because the control got transferred here. But when you want to use a go to, there are some rules are there. What are the rules? The first rule is you can't define the same label names in multiple places. I can't write there here also. 2 places you can't write the same name. You can't write. Okay, this is the first. You can have any number of labels of different name, not the same name. The next is the label cannot be put outside the function. It has to be only within the function. This is the main. It can be within the main only you can have. You can't put outside. Now, illogical use of go to will cause an infinite loops. What do I mean by this? Right now, I put a go to here, I put a there here, label I define it here. What will happen? After 3 is equal to 3, go to there will come here. When it comes here, again we'll start I is equal to 1 is less than or equal to 5, will print 1 is equal to 3 false, will print the high, it'll keep on repeating. Therefore, an illogical use of go to will cause infinite cycles, infinite loops. Therefore, cautiously you need to use. When you are defining a labels, you need to follow whatever the rules you used for naming variables. Like you can start with an underscore, you can start with a digit, you can have characters. All these rules which you studied has to be there. Now, instead of writing go to, if you would have written return, what would happen? If you would have return, what would happen? Now, instead of writing this, I wrote here what? Return. Okay, return. Returns needs a integer value because I told you in the first class we are returning an integer. I is 1, it prints hello. I is 1 is less than or equal to 5, it prints 1 is equal to 3 false, it prints a high. I became 2 is less than or equal to 5, prints 2 is equal to 3 condition is false, it prints high. I became 3 is less than or equal to 5, it prints 3 is equal to 3. Condition is what? Condition is true. Return. Return will take the control outside here, outside the function. Therefore, nothing will be printed out. Now, in the place of return, if I use exit, exit will take the control outside the program. Exit 0. So if you write outside the program, here I come, right? Exit 0 outside the program. Now look at this. Exit 0 takes the control where? Outside this. When I come outside, what I'm going to do here in this case is exit 0 takes where? Outside. Then you might ask a question, what is the difference between return and exit? Return will take the control outside of the function. You can have any number of functions, but exit will take the control outside of the program. The program is always in the main. It will always take the control outside of the main. That means once you put an exit anywhere in any function, it will take the control where? Outside. Okay? Outside of the program. Now I am going to put code on the board. So what you need to do, copy the code and then what you do, take the output for me and then we'll discuss that. Okay? Okay. If I modulus 2 is equal to 0, if j modulus 2 is equal to 0, continue, right? Otherwise, I'm going to say C printer percentage D J and I'm going to close it. The closure brace here and this brace. Before this brace, I'm going to have another statement printer /n and I'm closing. Okay, so pause the video, write in your notebook, go one line, execute it, come, we'll see what is the output should come. Okay, pause the video. So did you make an effort? Let's go. Okay, let's see. So what is the output? I should have got it. Okay, if I run this code. Now I is 1 is less than or equal to 5, condition is true, I come inside. J is 1 is less than or equal to 5, condition is true, come inside. 1 modulus 2, how much I get what? 1. 1 is equal to 0, condition is what? False. J is how much? 1. 1 modulus 2 is how much it is? 1. 1 is equal to 0, false. I printed what? 1. I go for after this J plus plus, J became 2. 2 is less than or equal to 5. 1 modulus 2 because I is right now 1 only. Okay, remember I is 1. 1 modulus 2 is 1. 2 modulus 2 is 0. Therefore, continue. Continue will take the control where? Continue will not execute the remaining statement, will take the control above. J became 3. 3 is less than or equal to 5. Condition is 1 modulus 2 is 1. False. 3 modulus 2 is also 1. False. It prints the 3. J plus plus 4. 4 is less than or equal to 5 condition is true. 1 modulus 2 is 1. False. 4 modulus 2 is 0. Continue. We will take the control where? Above. J plus plus. J became how much it is what? 5. 5 is less than or equal to 5 condition is true. 1 modulus 2 is 1 false. 5 modulus 2 is 1 false. I print 5. Now J became 6. 6 is less than or equal to 5 is false. I came out. I made a new line. Then I plus plus. I became how much it is what? 2. 2 is less than or equal to 5. True. I came inside. J is 1. 1 is less than or equal to 5. Condition is what? True. 2 modulus 2. What I get? 0. Break. Break will take the control where? Outside. I get another additional new line. I went for I plus plus. I became how much it is what? 3. 3 is less than or equal to 5. Condition is true. Come inside. J is 1. 1 is less than or equal to 5. 3 modulus 2 is 1 false. 1 modulus 2 is what? 1 false. I print 1. J became 2. 3 modulus 2 is 1 false. 2 modulus 2 is what? 0. Continues. J became 3. 3 modulus 2 is 1 false. 3 modulus 2 is how much it is what? I print what? 3. Now J became 4. 4 is not equal to 5. I is 3. 3 modulus 2 is 1 false. 4 modulus 2 is 0. J became 5. False, false, and I print the 5. Then I go for J plus plus. J became 6. False, I came out. I made a new line. Then I went for I plus plus. I became 4 now. 4 is less than or equal to 5. Condition is true. J is 1. 1 is less than or equal to 5. True. 4 modulus 2 is 0. Break will take the control where? Outside. Now I went for a new line. I became 5. 5 is less than or equal to 5. True. I came inside. J is 1. 1 is less than or equal to 5. I got what? This condition is false. Why? Because I is 5. This condition is also false because J is 1. It prints 1. The same I get 1, 3, 5. Finish. I come out. I became 6. I came out of it. Got it? Okay. This should be our answer here. Okay. Now let us solve a problem. How to use them in our problems. Okay. So if you like my session, kindly share, subscribe, and like. Let's take a simple example. I want to find whether the given number is a prime number. What is a prime number? You know, any number that divisible by 1 and itself. Divisible by 1 and itself. Any number that divisible by 1 and itself. Okay, so I have a number. I want to find whether 7 is a prime number or not. If you want to find 7 is a prime number or not, what I should do, I need to start dividing the number. I don't need to divide by 1. I start dividing the number from 2 to what? 6, as per the definition. Therefore, first, how do we know divisible? A number is divisible. The remainder would be what? Remainder would be 0. Okay. First time I'm going to divide the number by 2. 7 modulus 2 is 1. It is not equal to 0. Therefore, it is not dividing. Therefore, it's not dividing. Therefore, what I'm going to do, I'm going to divide by 3. 7 modulus 3 is how much it is what? Remainder is 1. It is not equal to 0. 7 modulus 4, remainder is 3. 7 modulus 5, remainder is 2. 7 modulus 6, remainder is 1. Therefore, now you reach the 7. Therefore, it is what is a prime number. You will say. Okay, now. That means you started dividing the number from 2 to n minus 1. You went there. If anybody divides, you are going to say not a prime number. Okay, let us take that case also. Okay, let's say 9. So first is you will divide the number by 2. 9 is not getting divided by 2. Therefore, what to do? Then what you will do? You will go to 3. But 9 modulus 3 is what? Is 0. It's dividing. If it's dividing, do I need to go till the end? No, because one number divides is over, right? One number divides, that means you were processing the data. While processing, you decided not to continue the process till the end. In this case, what you can do, you can stop it using a break. Using what, a break? Okay, let us see how to apply this in the program. So we have a number now. We need to find what we did. We wanted the denominator right now. So our denominator started from the 2 till where it went, till n minus 1, not up to n, right? N plus 1. What we did was, if we checked number modulus I, not 2, modulus I, because you have to keep on changing your remainder 2, 3, 4, 5 till up to what? N minus 1 equal to 0. What you did? If it is equal to 0, what you did? You stop the procedure. Correct? If not, if it is not, what did you do? If not, you continued. You need to go to updation, right? But sir, continue. Do I need to write it? No. Why? Because it will automatically go there only. Because there is no other statement below is existing. Right? Within this. Therefore, I don't need to write. Now, I need to say it's a prime or not a prime. How many times I should say prime or not a prime? Only once. Whatever you want to say once has to go where? Outside. Okay. I did not put inside. I put outside because I want to say only once. So then when I should say it's a prime, when I should say it's not a prime. If you put a print inside, it will keep on printing every time. No, I will write only once. So printf percentage d is prime. Percentage d is what? Prime. Okay. Else printf percentage d is not a prime. It's a composite number. Okay. I just said around that. What is the percentage we need to put here? In this case is n. Correct? Right. But my challenge is when I should say it's a prime. When I should say it's a prime is, one is you are going to come out of the loop for two reasons. Which are the two reasons? In the case of 7, your condition becomes false and you come out. In the case of 9, 9 modulus 3 became true, broken came out. That means if you break and come out, it is not a prime. If when you break and come out, your I value will never be equal to n. If I value is equal to n means what is the meaning of this? You broke the loop. You completed the loop. In this case, what I can say, if I is equal to n, I can say it is a prime. So I'm going to enter right now. Okay, you're saying I is not undeclared because I declared a variable inside the for. It's not visible outside. You have to declare it. Okay. I put it right now. I enter right now 9. It says it's not a prime. I am entering right now 7. It is saying it is a prime. I enter right now 11. It is saying it is what? Is a prime. Right? But sir, now you have broken so much of your head right now. Instead of this, you want to say if you break the loop means it is not a prime. Correct? Yeah. In this case, simple thing, you can use a Boolean variable. It's a flag. I am write flag is equal to. I am assuming my number is prime. When I am going to make assumption is false, I am going to find the flag is what? If I go inside the if, that means if number is getting divided by some number. I made the flag is what? 0. When I come out of the loop, the flag will have two values. One is either 1 or what? 0. If it is 1 means what? It is a prime right now. Therefore, simply you can say if flag is equal to 1, it's a prime. 1 is equal to 1 will give me the 1. Correct now is 1. Therefore, simply I can also say 1 flag. It's okay. You can say in this case, I will take entered 11. I got the answer is prime. I entered 21. It is not a prime. Correct? Okay. But sir, now let's go back to our analysis again. Okay. In order to say a number is a prime, what it did was you started dividing from 2 till n minus 1. If you want to prove n is a prime. That means if my n is right now 10,001, you know what? How many times your loop ran? It loop ran from 2 to 10,000. That is approximately 10,000 times you ran the loop. But we know it very well, logically speaking, there is no number is divisible by more than half of it. More than what? Half of it. That means it is not worth dividing 10,001 from 5,000 onwards. It's not worth it. Correct? Therefore, instead of wasting the time, we can save the time. How? I'm modifying the code. Instead of going up to n, go up to where? N by 2. You save your time. Let's put 11, whether it's coming or not. It's prime. If I put here 50, let's just say it's not a prime. But now we will further improve this code. Mathematically, it is proven if a number is getting divided, it's always getting divided on or before its root. On or before its what root? It is being tested. If any number is getting divided, it is always getting divided on or before its root of the number. Therefore, now I don't need to go up to n by 2 also. That means if it is 10,001, I don't need to go up to 5,000. I can go up to 99. That means I can save the time. So much time I can save the time right now. In this case, what change I can make? What change I can make? I want to make a change. Instead of putting n by 2, I need to put root of the number. How do I write root of the number? Integer s is equal to sqrt of. How do I write root of the number? And in this case, math is included. And I here I put what? S root square. Let us test as a simple number. Is 11 is a prime? 21 is not a prime. Yeah? Got it? So now I want to find all the prime numbers from 1 to 1000. In this code, I am giving only one input, correct? But you need to give how many input? What? 1000 input you need to give. And it's going to be in a sequence. So you can substitute the loop. That's what I'm going to do. Simple thing. I'm going to cut this out. And I'm going to put a for. Don't use I. Okay, why? Because I is getting used where? Inside. Okay. Therefore, I'm going to use integer. J is equal to 2. Because 1 is not a prime, right? J is less than or equal to what? 1000. J plus plus. Put it. I'm closing the brace here. Right? Now look at this. What I need to do? J is giving this. That has to be given to what? N, right? So N is equal to what I should write? J. If we run this, it's going to say 2 is a prime, 3 is a prime, 4 is not a prime. I don't need to write not a prime. I don't need to write and put a message also is prime, right? I need to print only this. I run the code. Yeah, okay. But sir, my output is not in one line, many are there. In one line, I want only 5 outputs. How many? 5. In one line, I want only 5. You know what I should do? Every time when you print, you need to count. Correct? If it is 5, then you need to go to the next line right now. So simple thing. What you have to do? You need to put a counter, right? Every time when you come inside, you're going to print, correct? If the counter is becoming what is the if the remain when I divide the counter by 5, if the remainder is becoming what 0, then I have to go to the next line, right? Hmm. See, modulus 5 is equal to if it is not equal to 0, do this. Okay, when I need to go to the next line is if the remainder is 5 right now. If C mod 5 is equal to 0, then what do you do? Go to the next line. How you go to the next line? Printf slash n. That's it. I'm going to code and put that. Yeah. So just tweak it. Learn to tweak the program and see. Okay.